we'll be using this
Cover it.
Saying it's technically a record of what's going on. Okay, so
Oh,
yesterday, we worked on.
she screwed up.
Just let it happen. Okay. Yesterday we worked on two different things. We worked on getting an understanding of why the angles and radians are what they are, and along with figuring out why the coordinate pairs are what they are. Now there are a couple things I actually want to add to this really quickly, but first let me show you a quick illustration. You don't actually have to put this in your notes, but if I was to go ahead and, we already did that one, go to here. Why do you think I have this slide? The unit circle has 4 different quadrants. Theoretically, 4 different quadrants you need to memorize completely. Why would I give you just one and say, hey, some of you, all you need to study is that one? Because you just change the signs and reflect to get to the other quadrants. So for instance, yes, yesterday we wrote it all down, and yes, some of you are just going to memorize that whole circle. Whenever we have a quiz or a test, you'll be like, can I just write the whole thing down from memory? I'll be like, sure, if you want to, have fun. But for others, we might not need to write the entire circle. Maybe you'll just write a quadrant, and for others, maybe you'll just make a table, and for others, maybe it'll all be up here, and hopefully whatever comes out is right. Okay, so let's focus just for a second. Question, what do we know about this first quadrant? You can use it, or you can try to be like, maybe I'll do it without the patty paper and see if I remember. Starting it down here, what angle is this? 0. 0 degrees, 0 radians. True? What point is this if the unit circle has a radius of 1?
1, 0.
Let's just kind of do the one that corresponds. What point is this one?
0. No, sorry, the point above pi over 2.
And what angle? 90. How do we have of remembering that it is 90 degrees? Well, it's half of 180. That's easy. That it is pi over 2, or 1/2 pi.
Half calzone.
Half a calzone. A calzone is only a semicircle, so half a there we go. So half of a calzone from your perspective would be pi over 2. Okay. Question. What do I know about this angle right here? It's 30, right? 30 degrees, true, because it's a little one. It's 1/3 of 90. Wait, what else is it 1/3 of? It's 1/3 of pi over 2, or it's 1/6 of who? There's 3 pieces here. There's 3 pieces over there. It's 1/6 of the whole calzone of the whole pi. Right? Now that's the angle. What did we see yesterday about the ratios? Now hold on, pause. My way of remembering it, to be completely honest and upfront, is that basically there are 5 important values of the coordinates in the unit circle. Why did I put them in this order? 0, 1/2, square root of 2 over 2, square root of 3 over 2, and 1.
Least to greatest.
Least to greatest. 0 over 2, whatever is 0. 1 over 2 is root 1 over 2, root 2 over 2, root 3 over 2, and guess what 1 is?
1.
Technically, root 4 over 2. I think there's a pattern to the unit circle.
What?
Root 0 over 2 is just 0, root 1 over 2, root 1 is just 1, root 2 over 2 doesn't simplify, root 3 over 2 doesn't simplify, root 4 over 2 is 2 over 2, which is 1. No. I wouldn't necessarily say that you should just memorize the pattern and have to reduce it every time, because that takes time. But if you can get down that these are the 5 different main numbers, and this is the smallest, and this is the biggest, all you have to think about for my visual people is whether you're going over a lot, or over a little, or over somewhere in between. Up a lot, up a little, or up somewhere in between. These ones are on the axes, so we kind of get to ignore those in the sense of looking at the in-between 3, the 30, 45, and 60. This one is my smallest, so I call him my little. This one is my biggest, so I call him, well, up a little, up. I say that he's a lot. And then this is my somewhere in between. This is my middle. What do I mean by that? Look at this point over here, guys. Are you going, in comparison to the over of this one, the over of that one, over the over of this one, are you going over a little or a lot or somewhere in between?
A lot.
You're going over a lot. Hey, guess what? He's root 3 over 2. Are you going up in comparison to the ups of the other ones? Are you going up a little or up a lot or up somewhere in between?
A little.
A little. That's all I think of. I just get an angle in the unit circle and I think over a lot or over a little or over somewhere in between. Now let's think of the next one. Hold on. Pause. What angle is he? There'd be two slices here, so there's two more slices. How much of pi is he? 1, 4. Or you can think he's 1/2 of 1/2, which is 1/4. Either way, I have him. Now question, hold on. I know some of you aren't visual, you're like, I just have to memorize. Okay, fine, just, respect the ones that are visual. Cool. Are you going over, in comparison to the other ones, over a lot, over a little, or over somewhere in between?
Somewhere between.
The middle, somewhere in between. Are you going up a lot, a little, up a lot, or up somewhere in between?
Between.
Up somewhere in between. Oh, sweet. Hey, look. 45s or over 4s are always going to be the same. We saw that yesterday. How about the last one? Ooh, this is a big slice. There's 1, there would be 2, and there would be 3. How much out of a calzone is he?
Third.
He's a third. Okay. Over a little, over a lot, or over somewhere in between?
Little.
Over a little, and up a lot, up a little, up somewhere in between.
A lot.
So over a little, 1/2. Up a lot, root 3 over 2. Oh, sweet, there we go, first quadrant. If you have the first quadrant memorized and you're doing it visually, you're good on the rest of the circle. As long as you can put the radians, as long as you can put it in the right quadrant. So for instance, if I was to ask you for 5 pi over 6, for those of you that hate fractions, 5/6 of pi, those of you that really hate pi, 5/6 of a calzone. What quadrant are you in?
2.
Okay. So here's your calzone, here's your semicircle, right? And you're just missing a little bit of a 6th. Okay, so hold on. Let's review them and say, let's say, 5 pi over 6, you're over here. Okay, so think about his coordinate. Ready? Back a lot, back a little, or back somewhere in between? Back a lot, right? Oh, sweet. So negative root 3 over 2. It's back. You have to go negative. Up a little, up a lot, or up somewhere in between?
Little.
Up a little. Oh, sweet. Here we go. Now, if you're not visual, you're like, I have no idea. Just bear with me. But you can still use the trick that, hey, a pi over 6 in this quadrant and an over 6, even though it's 5 pi over, and over 6 in this quadrant, they both have little 30-degree reference angles. They're both going to have the exact same points. But question, all the points in this quadrant are going to have what in front of all their x values?
Negative.
Because all their x values, wherever you're going, are all going to be backwards. So it's going to be a negative with, what are all the y's going to be if they're going up? Positive. What were all the points over here in this quadrant?
Positive.
Positive, positive. So without going through all the other angles, for those of you that are like maybe like the whole like lot little middle isn't really helping, you could at least hopefully do the reflection and say, hey, an over 4 over here is going to match up with an over 4 over here, and I'm going to have the exact same point but a negative x. Maybe you're just going to memorize this whole, hey, all the x's are negative and all the y's are positive, or as Mr. Crawford would say, all students, what? S sign. Sign is the y. Only the signs are going to be positive. Not cosine, not tangent. Can anyone fill in the angle for me real quick? What's supposed to be here?
2/3.
How can you do that visually? 1/3 plus 1/3 is 2/3. If you kept on going, 3/3, that would be at pi, right? And you would steal that point right over there, make the x negative, keep the y positive, and you would go. Okay, I'm not going to keep on going the entire way. However, you have the unit circle in front of you. Do you see how the symmetry keeps on going as you keep going down? The point is the same, except, wait a minute, what's true? Look at your unit circle. What's true about the signs in the third quadrant? What do you see? All the points, the x's are negative because you're going back, and the y's are because you're going down. It makes sense just with graphing. Then look at your unit circle again. What's going on over here in the fourth quadrant? Don't all of these mimic each other again? mimic each other, except what are the signs over here in the fourth quadrant? All of the x's are because you're going to the right to get there, and all the y's are negative because you're going down to get there. So for those of you that might not have learned all students take calculus last year, all means the x's and the y's, and so the tangent, so the cosine and the sine are both going to be positive, and tangent is y over x, well, he's going to be positive too. All students, I just mentioned him, let me say it again. Sine goes with the y. The y's are all positive, but everybody else is negative. Why? Well, cosine's negative, and if you do y over x, a positive over a negative is a negative. So tangent's negative. The third quadrant. All students, what's next? Take. What's the T for? Tangent. Why? Well, the sine's negative and the cosine's negative because the y's are negative and the x's are negative, but y over x, a negative over a negative, is a positive tangent. And all students take what? Calculus. C is for cosine. The x is positive, so cosine is positive, sine is negative, but y over x, tangent will be negative over positive, tangent will be negative as well. So some of you remember that all students take calculus, but you're like, what does that mean again? Oh. It's telling you who is positive between sine, cosine, tangent, who is positive in that quadrant. But if you just know how to graph a point, you don't necessarily need to stress about that because you're going to naturally say, ooh, a negative x and a positive 1. Okay, that's one way of thinking of the unit circle. How many of you guys are like, you know what, I think my brain kind of tracked in the over little middle lot. At least I get it. I don't know if I like it, but I get it. Okay, it's like half the class. Is there another way? Yes. But let's take a quick second and let's review really fast what we saw on this page of notes. Some of you are like, I'm not tracking with what you're saying because, okay, there are x's, there are y's, but why are you saying sines and cosines again? Why are you saying tangents again? Remember, whenever you have any coordinate point in your unit circle, I'm picking a random one, let me pick, who would be up here?
30.
That's not 30, 30 is a little baby one, right? That's 60, and how much of my calzone is it? A third. Okay? Pi over 3, but either way, whenever you have a coordinate pair, right? Wherever you are in the unit circle, that coordinate pair for this one, over a little, 1/2, up a lot, root 3 over 2. You have an x and you have a y. What does the x go with? Cosine. The x goes with cosine. What does the y go with? Sine. How do I find tangent? Him over him or him over him, right? If I was to do root 3 over 2 over 1/2, you're not going to like it, I know, but it's still possible. We'll get some examples before we're done today. Now, remember, I was going to show you multiple ways of doing the unit circle, but we do have to get through section 4.2 first. And then I'll show you another way besides my little, a lot in the middle. I guess I say little, a lot, and somewhere in between. All right. What kinds of homework problems are you guys going to see? For those of you that haven't started yet, because the deadline technically wasn't up there. And that's okay, we were just trying to get our unit circle down yesterday. You might be given something like, now, this is a very packed problem, so we're not going to do all of them. We're not going to do all of them. But let's do, I don't know. Let's do letter B. You want to do A? Let's do A. Let's do D.
Let's just see. That's easy.
Let's do D. C is easy, except sometimes he's undefined. Let's do D. Now, it says evaluate the 6 trig functions. Wait, there are 6 of them. Wasn't I just talking about the sines of 3? Okay. So we're going to have sine of negative pi over 3, cosine of negative pi over 3, tangent of negative pi over 3. How do I get the other 3?
I'm over there.
I flip it. Who flips sine? If you look at your
Cosecant.
table, who's 1 over 1? Cosecant. By way of remembering, I think I might have said this before, between a function and his reciprocal function, there's only one co. So if sine doesn't have a co, he needs a co. Cosecant. Cosine has a co. Well, he doesn't need one. It's just going to be secant. Maybe a silly way of remembering that only helps a couple, but hey, it helps a couple. Tangent doesn't have a co, so, well, he's a little bit easier because he's the only other one that has a tangent.
Can we just put sine of t?
Yeah, we could. I'm just trying to re-emphasize the fact that we're doing it at that angle. Okay. Now, hold on. Some of you are just going to be like, oh, I have it memorized off the top of my head. Most of us are going to need to visualize in the unit circle at least a little bit. If you were to look around your unit circle, is there any place labeled literally negative pi over 3?
No.
Maybe that's why I chose that. Well, how do we have to think about it? Hold on. Positive angles go what way? Up and to the left. Negative angles go down or clockwise. Oh. So I need to think of who is pi over 3 and then go down that amount. Well, guys, think about it. There's your calzone. If you have a third of it and you're going down, isn't it going to end up something like right around here-ish? Right? There's 1/3ish, 1/3ish, and then there you go. There's the rest. So there's our negative pi over 3. Could you match it up to a specific place in your unit circle? Yes. Who else is negative pi over 3?
5 pi over 3.
5 pi over 3, which is 1 pi over 3 away from 2 pi, or 6 pi over 3. Okay. You could just look at your unit circle and steal the points. That's one way. I'm just going to re-emphasize mine really quickly. Go over a little and down a lot. So over a little, that's a positive 1/2 as an x, and down a lot, that's a negative root 3 over 2. Either way. Isn't that what you guys have written on your unit circle? It's time to plug in. Who goes with sine? The y. Good. So negative root 3 over 2. Who goes with cosine? The x. So 1/2. Now, why do you think I write sine, then cosine, then tangent if it's y, then x? Who is tangent? Y divided by x. Focus and let everyone else. Y over x or sine over cosine. Take him. Take him. Imagine a big old division. So negative root 3 over 2 over 1 over 2. How do I simplify that? Because we're in math. We know they want us to simplify, not keep a nasty, complex fraction. Coolest thing ever about the unit circle. What happens if they're both over 2? Don't even do math. Just be like, hey, those can't go out. What do you do? If you were to multiply by the reciprocal, it would go away. If you were to multiply top and bottom by 2, it would go away. You can just say it goes away. What's negative root 3 over 1? Okay, we're halfway there. Whew. Now, which of these reciprocals are we going to like taking the most? Yeah, cosines, right? Secant. Because what's the flip at 1/2?
2.
Oh, whew, that one's nice. The rest, what are we going to have to deal with?
Stuff.
Radicals in the denominator, because if you flip sine, what do you get? 2 over rad 3, or root 3 with like a negative in front somewhere. Aww. How do we rationalize? Multiply top and bottom by rad 3. But hopefully we'll get to the point to maybe where we can do that quickly and get 2 rad 3 over 3 without having to show tons of work. That's just rationalizing. Multiplying top and bottom by the radical. Cotangent. Wait, how do you flip them? He doesn't have a bottom. If he doesn't have a denominator, what is it understood to be?
1.
1. So when you flip it, what are you going to get? Stink. He needs to be rationalized also. Okay, multiply top and bottom by rad 3, but maybe we can get to where we know that goes to rad 3 over 3 without showing all the work. It might take us a little bit of time, but hopefully we get there. Does it make sense how I found all 6? Using 2. Does that make sense? I found all 6 using 2. And if you're like, I don't know why, okay, go back to that little table. That's your x, that's your y. And that little table tells you sine is 1, cosine is x, tangent is y over x, cosecant is 1 over y, secant is 1 over x, cotangent is x. We'll talk more about this in terms of right triangles in another section, but for right now we're just trying to figure out those coordinates and how to get trig functions out of them. Do we have it? At least written down. Okay. So, okay, class page of notes. I know. A little bit of notes, and then we just get to do homework help / practice the unit circle. So hang in there. A few more things. Technically, I guess I should say a couple, but there are like lots of things written down below, so. 2 more categories. We're going to talk more about the range and period in section 4.5. In section 4.5. We're just going to write down now because there are a couple different things that it might be useful for.
Let's just skip lines under range and period.
Oh, we're just filling in one line.
Yeah.
I'll start filling it in now. That way you guys can fill it in as well.
Thank you.
Range. If you have sine of any angle, is actually restricted. So is cosine. And maybe, just by looking at the unit circle, maybe you can tell how. If sine and cosine both come from all different possible x's and y's in a unit circle. Remember how I had a little, a lot, and middle? I kind of left out 2. I left the smallest and the biggest. What was the biggest number that we're going to see for sine or cosine in the unit circle?
91.
Those are degrees. But like the actual x's and y's, the biggest is going to be 1. What's the smallest going to be? 0. Well, kind of. The smallest number is 0, but what's the most, take a number line, what's the most negative it could go? Negative 1. So it can go down to 0, but it actually can go to -1 as well, but it can't go beyond that. You're not going to have any sine values ever able to equal 2, or 3, or 10. I could explain that to you with right triangles, but that's not the point today. How opposite over hypotenuse. The opposite over hypotenuse can never be bigger than 1 because the hypotenuse is always the biggest side. And then cosine, adjacent over hypotenuse. Adjacent can never be bigger than hypotenuse. Hypotenuse is the biggest side. But we can also think unit circle and say, oh hey, well sine can only go between 1 and -1. Isn't that as far as cosine can go too? So they're both restricted. They both have ranges and they can only equal things in between those ranges. And they both have periods, meaning the entire cycle will repeat every time you get all the way around the circle and start again. So how many radians is that? 360 degrees. So how many radians? 2 pi. It's going to take an entire 2 pi, an entire rotation to start the entire cycle over again. So as you go from one quadrant to the next, the signs change. At least of 1. So it's going to take 360 degrees or 2 pi. But as we learned in last section, you do have these things called coterminal angles. And so if you had an angle that went all the way around the unit circle and then it started over again, it's just going to hit at the angles we already have so we can seal their answers because it's going to have the same ratio. It's just going to repeat. That's why the note right down below says trig ratios are the same at coterminal angles. Now that last little table you guys are writing, sorry, it might be a little bit too low for people in the back. You guys talk about even and odd, the symmetries, remember? We talked earlier in chapter 1, maybe a little bit in chapter 2 about symmetry. And they're just telling you which ones are even versus which ones are odd. Even functions stay the same whether the angle is positive or negative. Doesn't matter, they stay the same. Odd functions, it flips or changes some. I can actually kind of show you this real quick. If we go back, oh man, most of them are odd, right? The only even ones are cosine. Well, cosine and his reciprocal, secant. But let me show you why just for a second. We won't take a lot of time. Didn't I, there's a few slides ago. Didn't I write down with points where x's and y's are negative and positive, right? Let's go find that. Oh, this one. Okay. Remind me real quick. X coordinates go with what? Cosine. And y coordinates go with what? Sine. Okay, good. So then looking over here, a positive angle goes up, a negative angle goes, let me review it, goes down, right? A positive angle goes up, a negative angle goes down. We just have to say, hey, whose sign stays the same whether you plug in a positive or a negative, and whose sign flips? Well, guys, the one that stays the same is who?
Cosine.
Cosine stays the same. His sign is the same. So cosine is going to be the only one, well, and reciprocal, because 1 over secant is 1 over cosine. Cosine's the only one. If you go up and you go down, his sign stays the same. But what happens to sine? It flips. And so tangent, what's tangent going to do? Well, tangent flips too, because tangent's positive and then tangent's negative. So everyone else is going to flip except for cosine. Cosine stays the same, and that's the definition of even. So coming back, cosine stays the same, secant stays the same, whether you go up or down an angle. And it could even be like up an obtuse angle and down an obtuse. So you're still going to see the same pattern if you went back and looked at those signs. But everybody else flips, so everybody else is odd. Okay, I know you guys are still writing. A couple more seconds. We need to do homework helps / unit circle helps till the end. All right, are we close? Oh, a little bit longer. Your ear's not turning on today, huh? Got it? Almost. For those of you guys that are done, let me go ahead and try to dual page it. It's going to be kind of small, but hopefully it gives the idea to those that are still writing. I guess it's a lot smaller. Okay, why don't you go ahead and write down the next example. The only direction is evaluate. What does evaluate mean? It's now the way of saying solve. Finding who he is. Sine of 9 pi over 4 equals, it's a number. It's either positive or negative, and it's one of those special trig ratios, y. How do I know that without even finding it in the unit circle? What's it over? 4. Aren't fourths in the unit circle? Thirds, fourths, sixths? Yeah, they're all there. Okay, I know he's in the unit circle, so I know, well, technically, don't you have a 20% chance of getting it right if you just guess?
Yeah.
Kind of.
That's pretty good.
You really have a 10% chance. How come? Could be positive or negative.
10% is 1 out of 10.
Yeah, 10% isn't quite as exciting. But if you can figure out the sign, and you have a 20% chance, if you know he's not on an axis because he's a 1/4, you have a 33% chance. We're getting better, right? Okay. Let me go ahead and zoom in on this example. 9 pi over 4. Is he written down on a unit circle?
Yes. No.
No. Is he literally written down? No. What? Hold on. Look at your unit circle. You have 1/4. What else do you have? That's in the first quadrant. What do you have in the second quadrant? 3 pi over 4. Because 2 pi over 4 is a half. Then what do you have in the third quadrant? 5 pi over 4 because 4 pi over 4 is a half. Then you have 7 pi over 4. Well, where's 9 pi over 4? Well, he is in the same quadrant as one of those ones, right? He's coterminal with somebody. Now, the easiest way I have of thinking about, now, you might totally disagree and that's totally fine. The easiest way I can think of is to see it as 9/4 pi, which means mixed numbers might shed some light on the situation. What's 9 over 4 as a mixed number?
1 and 2 and
2 and
1/4. What?
whew, that's right. 4 goes into 9 how many times? Twice. 1 left over. Okay. 2 and 1/4. What does this mean? Oh, it's bigger than 2 pi. So you go 2 pi, and then after you go 2 pi, remember it's all the way around, then what do you go? What's extra? 1/4. Well, where's 1/4 pi? Oh, he's right there. Go 2 pi, and then go a little bit more. go 2 pi and go 1/4. Now, if you don't like that way, we were just counting by fourths, right? 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4. Where would 9/4 be? You could get there just by counting by fourths. Either way, 9 pi over 4 is going to coincide with what angle? Pi over 4. 9 pi over 4 is coterminal with, or is going to have the same ratios as pi over 4. It repeats, and since it repeats, I'm like, sweet, I'm going to steal the answers from pi over 4. So if you guys think about it with your different angles, it's going to go over, in between, up, in between. Square root of 2 over 2. The ones that memorize, you just steal the y. You can kind of cheat on this one, the x and the y are the same, so you just hope you, well, I'm glad you have it right either way. For those of you guys that are more geometric and over 4, 180 divided by 4 is always 45. It's a 45 degree. 45 geometry triangles have a root 2 in them. Oh. This trick works, by the way, if you have a third. 180 divided by 3 is 60. Oh, 60s have 1s and root 3s in them. 180 divided by 6 goes with a 30 degree. Interesting, which also has a 1 and a root 3. You have to figure out which one it is. But anyway, those are little tricks also. So we end up with root 2 over 2 and we're done. So not only can we find trig ratios of angles between 0 and 2 pi, we can even find ones that are bigger. We just have to figure out where they end, what angle we should use, okay? What about this one? Say what? They don't even give me an angle. Did you write down formulas with negative t's in them?
Yeah.
Couldn't you look at those formulas and say, hey, sine of negative t is? Just the formula says
Negative sine of t.
negative sine of t. You just write down the formula. You can say, oh, wait, hold on. Who are they telling us? Plug it in. So therefore, if I just write down the formula, I can say, sweet, I steal the 1/2 and I put a negative with them. Dun, 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 dun. Visually, we'll look at it in a second. What's the formula? Wait. You know the formula on this? Right? Didn't you write the one with t's? Like literally just
Yes.
like a minute ago? Sine of negative t equals, fill it in,
Yes.
negative sine of t. Steal the sine of t, plug it in, done. Right? Plug it in for him. Now, cosecant, doesn't he have a formula? Good, you're looking. What's cosecant's formula? Cosecant of negative t is? Yeah. He's going to be the same thing as sine. So I'm going to plug in. Oh, wait, who's cosecant?
1 over sine.
Maybe I need to take a second and say, uh-oh, cosecant of t, who would he be? Oh, he's 1 over, right?
2.
1 over sine. So he's 2. Okay, now go plug in. It's going to be what for cosecant of negative t? Negative 2. And for those of you that are more visual, did you figure out at what angle sine is 1/2? Yeah. Up a little. Who's up a little? Oh, isn't that a pi over 6 or a 30 degree? Okay, at this one, sine is, remember sine's the what? Sine is a 1/2. If I go down that same amount, for negative t, if I go down that same amount, aren't I at 11 pi over 6? Aren't I at negative 30? And what's sine there?
Negative.
Down. My visual ones, maybe we can do it just by actually placing it in the unit circle.
How do you know it's not on the other
Oh, good question. So what if it was on the other side? Because technically in your unit circle, if you guys look, 5 pi over 6 also has, and it's a little too high, sorry. Oh, shh, don't judge. Okay. This one, negative root 3 over 2, positive 1/2. Well, what if it was this one? Okay, fine. Does it make a difference?
Nope.
Let me get up here a little more. Doesn't sine flip however you look at it? Whether it's from this one to this one, or whether it's from this one to this one, doesn't matter. Okay. What else do we have?
Nothing.
Oh, well that's exciting. Unit circle. Ready? We've talked about the different types of homework problems you might have. That homework is due on Monday, etc., etc., etc. However, hold on, I have a pretty copy of what I'm about to show you. Where's my pretty copy? What?
Well, I saw that. Oh.
Don't worry, I change it every year. Cheater chart, that's what I want. Guys, have we already talked about triangles? Kind of, right? And then the cheater chart? Alright. Don't worry, I erased them in triangles. We did talk about how to get 1/2 root 2 over 2 and root 3 over 2. We did talk about that. That's good, Mel. However, there is another way to use triangles that some of you might like. It's just to stick with the good old-fashioned geometry triangles that we already talked about. There's 30, there's 60, there's 90, with the 1, 2, root 3. And then there's your 45. Let's not do any weird dividing by. That's 45 and 45. And there's your 60, 30. These are approximations, don't judge. Okay. We have our 1, our 2, and our root 3. Okay. We technically could just not divide anybody. We could not divide anybody. And we could think of SOHCAHTOA. For right now, I'll just show this one. This is technically going back to right triangles, but for some of you, it might help you with the unit circle now. We're doing right triangles in the next section. Oops, go back. What's SOHCAHTOA? Do you remember? Opposite over hypotenuse for sine, adjacent over hypotenuse for cosine, and opposite over adjacent for. And we're using these little angles that are right by the center of our circle, like we did yesterday. We kept on pinching the center when we were folding. How does this help? Well, let's say I was to give you something like, okay, and this could be, if you guys saw that pop quiz, it was, I don't know, it was another year. You can look at it. Here it is. Yay. What am I doing? Giving you a random angle and asking you for a random trait. Right? Okay. So what if I gave you one of those? Let's just steal the first one. Sine of 4 pi over 3. What's the very first thing, almost no matter what way you study the unit circle, that you have to think of if I say 4 pi over 3? Oh, where is it? Okay. I've been dealing with calzones, dealing with pies, dealing with counting by fractions, all this stuff. That all works, and I'll show that in just a second. But if some of you just detest radians, couldn't you just say, forget it? I'm just going to convert you. Couldn't you? Just go to degrees if your mind literally just can't handle radians. You could go ahead and cancel out the pies. This is where my trick comes in. What's 1/3 of 180?
60.
60. You have to go 4 60s. And some of your minds can do that. Oh, 240. 90, 180, 270, 240. Okay, maybe you can do that. But others of you, well, you might have to count around anyway in your unit circle. And say, well, hold on, 60, isn't that the up one? There's 160, 1/3 pi. 260, 2/3 pi. 3 60s, 3/3 pi. 4 60s, 4/3 pi. It's kind of like my counting by fractions. 1/3, 2/3, 3/3, 4/3. There he is, third quadrant. Anyway. Question. What triangle am I going to fit into this space right here? The 60-degree one. So if I was to fit, now technically it doesn't fit in the unit circle. The unit circle would be kind of like here-ish, and the triangle's going to come out to here-ish, but it doesn't matter. We're just looking for the ratios. So let's get away with that yucky circle, because we're not even worried about him. And we're just saying, okay, let's throw in a triangle. Which triangle? That one. And when you throw in that one, you can say, okay, this little side is going to be a 1, but he's left, so negative. The long side is going to be root 3, but he's down, so he's negative. The radius is always
2.
Positive. And then you can say, okay, there's my little angle. He's my opposite. He's my adjacent. And he's my hypotenuse. Huh. How do you find all 6 trig ratios? Sine equals opposite over hypotenuse. That's in my unit circle. Cosine equals adjacent over hypotenuse. That's in my unit circle. Tangent equals opposite over adjacent. Oh. It makes it a little bit nicer because there's none of that weird divided by 2 stuff. Long story short, who are we looking for? Him. And sine is opposite over hypotenuse. If I got it in my mind, I would say down a lot. Negative root 3 over 2. This is one way to use triangles. You put a little triangle in for his little sides, and you can solve for whatever you need. You just need to know SOHCAHTOA and SOHCAHTOA. That's coming pretty good. Now, cheater chart. We're ending with this. I'm going to go ahead and draw somewhat nice, because someone this year already is like, if you don't draw it nice, I kind of just spaz out a little bit, start to twitch nervously. Okay, fine. Drawing it somewhat nice. Stop. Somewhat nice. You should wait and see what I'm going to draw tomorrow when I'm trying, Monday, when I'm trying to show you how fast I can do this.
Oh no, where are they curving?
I don't know, just because. Because I'm tall and I'm coming this way, I'm trying to have you see it. So much judgment. Can you stop?
No, we can't.
Yeah. No, tell me about it. Is that better? You've done it before and then you've erased the whole thing. I'm not going to. Okay, so, question. What's the cheater chart?
No.
You ready? I want you to tell me when it hits the 9 and say go when it hits the 9.
5 seconds. Math is taking.
Go.
Go! You're bad.
CES.
Oh.
This is like a test guy.
Well, I can't see it.
Oh,
When you do it in 15 seconds, it's not going to break the world record.
Oh.
What?
Yeah, let's hear it.
Okay. Yeah.
Wait. What? Pause. Didn't we just talk about any angle can be reduced down to whether it's a 60 away or a 45 away or a 30 away? So if we were to do the same one, sine of 4 pi over 3, you still have to figure out third quadrant. You're like, oh, what's the sine? Oh, that's a 60-degree one though. And its sine is going to be a negative. You could go to your cheater chart and say, hey, it's 60, it's sine, it's negative. Answer. Now pause. That only took me about 22 seconds, something like that? Could you get down to where we could draw this in 20 seconds?
No.
Real quick, life story. Ready? I have a minute. Okay, there was a girl. She's now like a successful businesswoman. Anyway, from online connections too. But either way, she came through Heritage. She couldn't make it past Algebra 2. I never had her as a student, but she'd come and hang out because kids used to do that. Anyway, coming back. After she went to college, she took a math placement test. They placed her back in geometry. She had to get through business calculus because of the goals of wanting to be a financial advisor for people. Okay? She was like, I started tutoring. We went all the way up through business calculus, and she was basically acing math by then. Not saying it was because of this, but she figured out, not me, she figured out this chart was how she could get the unit circle right every time. What would she do? She would write it down at the beginning of any test, any quiz, anything that had the unit circle. She would write that down, and she'd be able to find an angle. She would actually convert to degrees. She would convert to degrees, get to the quadrant. She would know all students take calculus, and she would steal an answer from her. It's an idea. If nothing else works. Kiddos, this weekend you're studying the unit circle. We're doing a quiz next week, and we're doing dum-dum quizzes. You didn't get to today. But Monday. Bye, guys.
Have a great weekend, sir.
You too. Study that unit circle. Study. Bye, guys.
A bunch of random flyers that I was helping figure out what to do with. Oh yeah, sure.
So I'm definitely coming up to an entire giant box of products wherever I go.